Hello, my name is Dear Vincent and I go to 7 at school, and this is my project on how to grow microgreens using fish waste as a fertiliser. I've numerically compared two methods with a control method. For the first method, I cut some holes in the styrofoam. Then I placed a wick through it. After that, I placed some hemp into the hole and put some cress seeds on it. The wick sucked up the water due to capillary reaction. For the second method, I cut some channels so the water would flow through it. Then I placed some hemp on it and then I planted microgreens in it. I connected that solar panel to this pump which pumped water into the channel. This is the control method and it shows what the microgreens would look like with non-fertilised water. If we connected the solar panel directly to the pump would not have enough power to work. I made this little capacitor circuit so that the solar panel would charge the capacitor for a few seconds, then suddenly discharge into the pump. Let me explain how the circuit works. We use the switch to connect the solar panel to the capacitor. We turn the switch and we connect the capacitor to the pump, but obviously I can't spend all day turning the switch side to side. Instead of turning the switch on and off, we use a relay, which is an electromagnetic switch. It turns on when you give power to it, and it turns off when you remove the power. All we need now is a little timer, which sends electricity to the relay for a few seconds and stops sending it. This keeps on repeating. I used instructions from the internet and made the circuit on a breadboard. Now let's compare the two ways with the control method by measuring the plant growth during various days. At first, I tried measuring the plants at where they stood with a ruler, but then initially realised that it wasn't a very accurate method. I would uproot a plant and paste it on a piece of paper and individually measure them. Instead of using a ruler, I used a vernier caliper because the smallest unit on a ruler is 1 millimeter and the smallest unit on a vernier caliper is 0.1 millimeter. Because different plants on the same day have a different size, I have to get many samples and work out the average. There is a problem in measuring the roots. I realised that bigger plants could have smaller roots and smaller plants could have bigger roots due to the way I plugged it. So I have to cut off the roots at the point of germination and remeasure them to minimise errors. These are my observations. This is the unfertilised water base, our control variable. This is our fish water wick. It sucks up the water using a wick. This is using fertilised water. This is our fish water stream. It uses a pump to pump the fertilised water into the stream. I've used 10 samples each day across the account of 4 days. Day 4, day 6, day 8 and day 10. I inputted my measurements onto an Excel table and calculated my averages. This is the fish water stream, the fish water wick and the unfertilised water base, which is our controlled variable. This is a comparison of all three methods. On the x-axis, it carries the number of days, and on the y-axis, it's the growth in millimetres. The red one is the unfertilised water base, the orange one is the fish water wick, and the green one is the fish water stream. It is clear that the fish water stream grew at a faster rate. In addition to measuring the size of the plant, I also measured the amount of fertiliser in the water. For this, I used a soil testing kit, which measured the nitrogen, phosphorus, potassium across many days. Using the pipette, I'm going to measure 3 millimetres and put it inside the test tube. Now I'm going to put 0.5 ml of nitrogen test solution into the test tube. After 5 minutes, I waited for the colour to settle, so then I compared it with the colour chart. It turned out to be high in nitrate. I tabulated the results for the amount of fertiliser in the water, unfertilised water and fertilised water, throughout day 2 to day 10. The numbers on the chart correspond to the amount of fertiliser in the water, from high to low. However, for the fertilised water, we can see that there's a drastic change in the amount of nitrogen and a small change for the amount of phosphorus. But in the potassium, the level is staying the same and there is no change. And in conclusion, I can say that organic fertilised water from the fish tank is way more efficient than unfertilised water. Within the fertilised water, I can conclude that the fish water stream was much better than the wick. Using this method, families can now grow organic microgreens for their salads within 10 days.